So today as we move into lesson 2.5, let's put that at the top of this notebook page that we are on lesson 2.5, first of all. And then let's give a kind of a little title that talks about what our learning goal is. We are going to be solving inequalities with variable terms on both sides. Okay, so what are we doing in this practice? Have we done that before? With equations, have we not? Okay, what do you think might be, do you think anything's going to change? Probably not. We should be able to simplify. We know how to simplify. What are the simplifying steps? There's two of them. Look to see if you have to do any distributive property. That's a simplifying step. And what's the other simplifying step? Combining like terms. And when we talk about combining like terms, that's terms that are on the same side of the equation or inequality. Those are the simplifying steps. And then the solving steps start when we start doing the same thing to both sides. Well, we should be able to follow the same procedures, except what have we learned is true when we are solving inequalities. That we have to keep in mind, always, always, always. Brady, do you think you got it? Okay. When you multiply, Jay, by a negative number, yes, then the inequality sign switches, it reverses, it flips over. When you multiply or divide by a negative. That doesn't mean just because there's a negative involved in the problem, it switches, it's when we do that by. So we just follow all the rules for solving equations, except we are going to be able to, we have to keep in mind that if we multiply or divide by a negative, that then we are going to have to switch the symbol. Okay, number one, let's do some practice here. Practice, let's put that. The first problem that we are going to practice, write it down, 7 plus 4x is greater than or equal to 3x. 7 plus 4x is greater than or equal to 3x. Okay, what would be a smart first move to make in this one, Austin? Subtract 4x from both sides, okay? So, are there options? Do we have a variety of options of what we could do first? Yes. Could we, give me another option that we would have?
Subtract 3x.
We could subtract 3x from both sides. What's another option that somebody might try?
Subtract 7.
Subtract 7. So we have all kinds of options for starting, but when there's, by the way, was there any simplifying to do in this one? No. So there's no simplifying to do. Once you're ready to start solving, you get to make that decision what's going to be that first move you make. Some moves are just smarter than others, okay? They just save you some work, okay? So what's our inequality read now?
7 is greater than or equal to -1x.
Okay. 7 is greater than or equal to -1x. Next move. Braden?
Divide both sides by -1.
Divide both sides by -1. We're dividing by a negative, so we want to what? Switch the sign. We want to switch the order of the inequality symbol. So we are going to have 7 divided by -1. -7 is less than or equal now to x. Or what's the other way this can be written?
X is greater than or equal to -7.
X is greater than or equal to -7. And just as we've always been doing, what are we going to do? Graph it. Okay. And on that graph, we are going to have the endpoints -7 and its neighbors that are what? -6, and
-8.
those are called those are called integers. Those are called neighbors that are integers, okay? So, should I shade that circle in like I did?
Yeah.
Why?
-7.
It's part of the solution, okay? What other numbers are?
-6.
-6 in that direction, head that way, okay? Now, too many times in all this correcting that I'm doing of inequalities, and students are getting maybe the algebraic solution right, but then the graph wrong. What could guarantee that we shaded the correct side here? Just a quick guarantee that we shaded the correct side. Devin?
Put like -6 in for x.
Yeah, put -6 into our solution, our algebraic solution, and see if it's true. Is -6 greater than -7?
Yes.
Yes, it is. So then we can say with confidence, we at least feel like our graph matches our algebraic solution, right? Questions? Okay, number 2. We are going to solve 4 times the difference of 2 and x is less than or equal to 5 times the difference of x and 2. What would be a good thing to do in this one first?
Distributed.
Do the distributive property, do the simplifying. We're not going to start solving this yet until we simplify it. So we are going to distribute the 4 over the 2 minus x, and we're going to distribute the 5 over the x minus 2. So we have 8 take away 4x is less than or equal to 5x, take away 10. Any other simplifying we can do? Any other simplifying?
No.
Okay, then we're ready to solve. Okay, go ahead, solve this. You make the choice which first move you're going to make, and go from there. Somebody check out my first move. Do you think it's a good one?
No.
Would it even be a correct one?
No.
No. So, too many times I'm seeing that students see this subtraction sign here, and they think, well, since 5x is being subtracted, I need to add it. Is 5x being subtracted?
No, 10 is.
No, it is not. It's the 10 that's being subtracted, isn't it? So that would not be a good move at all to make. Okay, I'll let you work. When you're done, let's see if we agree. We have the same solution. Okay. Anybody's written differently than mine?
Yes.
Okay. How else could it be written?
X is greater than or equal to 2.
Yeah, x is greater than. We have that option. Greater than or equal to. Why is my board skipping there? Okay. And did you graph it?
Yes.
Okay. Make sure you graph it. How do we know if we got the right endpoint? How do we know if we got the right endpoint? That 2 is the correct answer there?
No.
You have to plug in if we're checking the endpoint, we have to plug in 2 into the original inequality, don't we?
Yes.
So we would go all the way back up here to the beginning and we would put 2 in. What's 2 take away 2?
0.
What's 4 times 0?
0.
0. Oh, what's 2 take away 2? 0. And what's 5 times 0?
0.
Oh, well then apparently our endpoint is correct. Okay. Do you think there would be any other number that would make it true? No, probably not. Chances are not. And so then now after this, then we would check one of the integer neighbors according to where we get our shading. And so which integer neighbor would we check here?
3.
3. That we can check in here. We can say, is 3 greater than 2 to see if we shaded the correct side. Yes. So once we check the endpoint, we don't have to take that 3 all the way back up to the beginning and check it necessarily. We can just check it in our algebraic statement. Now, if you want to make sure you have the algebraic statement right, that it shouldn't have been is less than or equal to 2, then you should check that neighbor up in. Once you're convinced that you shaded the correct side, then you could check that neighbor up in the original to make sure it makes it true, okay? So let's go do that. Let's do 3 because it won't take us very long to do that. Well, come on. What's 2 take away 3?
-1.
-1. And what's 4 times -1?
-4.
Okay, and then we have is less than or equal to, what's 3 take away 2?
1.
1. And what's 5 times 1?
5.
5. True or false? 4 is less than negative 4 is less than 5. True. Feeling pretty good about everything. We checked our endpoint, we checked our shading side, we checked that neighbor that was in there. I'm feeling like we got 100% on this. Okay, questions? Okay, number 3. Write down the following inequality. 3 times 2 minus x, this is looking familiar, is less than 3, -3, make that a -3, thank you, times x minus 1. Okay, what are we going to do first? Yeah, we got to do distributive property. We have to simplify. Okay, so let's get the simplifying done. What's the left side of the inequality look like after we've simplified? 6 minus 3x, okay, is less than -3x. This is where we have trouble, don't we? 3. If I do this, add the opposite, I'm taking a negative times a negative, which makes it a positive. Makes it a positive. Now, notice, I want you to be really careful here. We are not solving right now. We are simplifying. And we did some multiplying with a negative number when we were simplifying, didn't we? So should that reverse the inequality symbol? No. The rule is not for when you're simplifying. The rule is for when you are solving, when you're doing something on both sides, the same thing on both sides, when you're in the solving process. Okay, is this done being simplified?
Yes.
Okay, let's go to work then. What should we do?
Subtract 3.
You know what? My brain just wants to go straight to the fact that there's variable terms on both sides. I want to deal with that.
Add 3.
Add 3x. You know what? I don't care about those constants right now. I'm concerned about the fact that I have variable terms on both sides. So who cares about the 6? Who cares about that 3? I care about those variable terms. So now, what do I have on the left side of this inequality? 6. These cancel out, don't they? They're gone. Is less than 3. Oh, these canceled out on this side too. Oh, what happened when the variable terms disappeared totally in solving equations? What did that mean? There's going to be 2 possibilities. No solution, no real number solutions, or all real numbers. So either there are none, or the whole darn number line would work. Well then, how did we determine when it was which of those? How do we know when it's a no solution versus an all real numbers solution? When what? If the resulting statement is true or false, right? If it's true, it would be all real numbers. If it's false, it would be, okay, is ours true or false?
False.
This is false. So what are we going to say?
No solution.
No solution. And if there's no solution, do you remember the mathematical symbol for it? Yeah, empty set. If it's no solution, do we need to grab it?
No.
No, we just make an empty number line, right? Okay. Questions? Okay, next one. Give myself some more white paper here. Okay. What number are we on?
4.
Okay, number 4. 4 times the difference of x and 1 is less than or equal to 4x. What are you gonna do first?
Distributed.
Distributed property, simplify. Ready to solve? Okay, what should we do? Subtract 4x from both sides. There's variable terms on both sides. Let's deal with that. So subtract 4x from both sides. So on the left side, what do we have? Negative 4. On the right side, what do we have? 0. And yes, it's important we put that 0 there. 0 is a number. It's what's left. Nothing. 0. Okay? So this again is one of those what? Either it's no solution or all real numbers. Okay? So we have to check to see if this is a true statement or a false statement. True or false?
True.
This is true. Negative 4 is less than 0. So we would say this is an all real numbers solution. The fact that we got that statement and it's true, that's not where we stop. We still have to talk about the solution. The solution is all real numbers. Well, what's the mathematical symbol for that one again?
It's 2 lines.
2 lines, 2 vertical lines,
Yes.
and R. Yeah, this is our all real numbers symbol. You don't want to have to write out all the words. It's not ARN. So when the variable eliminates, that means we have to think about, okay, is this a true statement I'm left with or a false statement I'm left with? Because then I can decide is it a no solution or an all real number solution. Okay, so no questions about that. Okay, one last one then, number 5. And this is we have to write some words out first. So if you're kind of running out of room on the front side of your paper and you're need to move to the back, you might want to do that now. So write out this for me first, what I'm writing. 4 more than twice a number is greater than 2/3 of the number. Okay, so that's written out first of all. 4 more than twice a number is greater than 2/3 of a number. What if the word greater was there? Would that make a difference? If I just, for the fun of it, I changed this word to greater, or greater than. Would it change that?
No.
Because how are we going to replace 4 greater than twice a number, first of all? How would we write that expression? 4 plus 2x. Well, remember, x is what then? We always describe our x. X is the number.
The number.
Yeah, the number. The number they're talking about in the problem. X is the number. So 4 plus 2x, 4 greater than, 4 more than twice the number. Why is that not the inequality symbol that points to the right? What word is missing that says to you, you know what, this is not showing me an inequality symbol, it's showing me addition instead? Is missing. Is missing. If is had been here for is more than or greater than, now that's an inequality symbol. But that's not there. There's no is there. So this means addition. Oh, I need my pen now that I lost all that. This means addition. So that's why we have addition there. Twice a number is greater than. Oh, right there, there's our inequality symbol, right? Is greater than. Does it say or equal to?
Oh.
No. 2/3 of the number. What would we write for that? 2/3 x. So we have to be able to set up the inequality statement properly before we even want to try and solve it. I'm gonna suggest that there would be a really good first move to making this one, so you could just be like, oh, I'm so glad that fraction's gone.
Times 3 over 2.
I don't even wanna do that, because then I'm just gonna create some more fractions, possibly. Times 3. Couldn't we just multiply every piece times that denominator?
Yeah.
Yeah, let's do that. Let's take every piece of this inequality times 3. So I'm putting the pieces of the inequality in parentheses, taking each piece of the inequality times 3, because over here, when I put that 3 over 1 and make it into a fraction, I'm taking a fraction times a fraction, and what can I do with those 3's?
Simplify.
And how do we simplify? We just do what, basically? What's our word for that? When you're multiplying fractions and you can
Reduce.
you can cancel, reduce, yeah? So I could go like this, right? And now we have 3 times 4, which is 12. 3 times 2x, which is 6x, is greater than, do we multiply by a negative? No. And we have those 3's that canceled, so we have just 2x over there. Now it looks a whole lot better. Get rid of the fraction. Okay, go ahead and solve that. See what you get. You may not have used the same solving step I did to start with, so yours may look different, but what should be the case? We still should get the same answer, shouldn't we, in the end? So if you move the 2x instead, or the 6x I mean instead, you probably ended up with your statement reading differently than mine does, correct? So x is greater than -3 has to be the solution for this. And of course we always graph these. So which integer neighbor lives over here to the left? -4. And the integer neighbor over here to the right is?
-2.
-2. And is -3 a solution? No, it is not included. There is no equal to. And headed in the greater than direction. Okay. So questions about that one at all? No? Okay, then let's go back to our anticipation reaction guide. Let's go to that.